Hi, I'm Seek. Let us look at some exciting stuff. Do you know what is the connection between a ketchup bottle and a gigantic crane? On the face of it, no connection at all. But think about the science behind them and you'll reach a surprising conclusion. Ketchup bottles and cranes use the power of moving liquids in a very similar way. This technology is called hydraulics and it's used to power everything from car brakes and garbage trucks to motorboat steering and garage jacks. Gases are easy to squash. Everyone knows how easy it is to squeeze a balloon. Solids are just the opposite. If you've ever tried squeezing a block of metal or a lump of wood with nothing but your fingers, you'll know it's pretty much impossible. But what about liquids? Where do they fit in? Since liquids easily flow from place to place, you might think they'd behave like gases when you try to squeeze them. But in fact, liquids are virtually incompressible, much like solids. The fact that liquids don't compress easily is incredibly useful. If you've ever used a squeezy ketchup bottle, you've used this idea already. You've probably noticed that it takes some effort to squeeze out ketchup from the ketchup bottle. When you press the bottle, you're actually putting pressure on the ketchup, and that's why it squirts out at a much higher speed than your effort. If liquids weren't incompressible, ketchup bottles wouldn't work properly. You'd squeeze the bottle and the ketchup inside would simply squash up into a smaller space. It wouldn't shoot out of the nozzle as you'd expect. When you press the ketchup bottle, you apply a relatively large force to squirt out a small amount of ketchup. Because the liquid won't squeeze into a smaller space, it gets forced through the body of the ketchup bottle to the narrow nozzle and squirts out with less force but more speed. Now suppose we could make the ketchup bottle work in reverse. If we could shoot liquid into the nozzle at high speed, the liquid would flow the opposite way and we'd generate a large upward force on the bottle body. If we scale this system up many times, we could generate a big enough force to lift things. This is exactly how a hydraulic crane works. If you squirt liquid through a narrow tube at one end, you can make a plunger rise slowly but with a lot of force at the other end. The science behind hydraulics is called Pascal's principle. Essentially, because the liquid in the pipe is incompressible, the pressure must stay constant all the way through it, even when you're pushing it hard at one end or the other. Now, pressure is defined as the force acting per unit of area. So if we press down with a small force on a small area at the narrow end of the tube, there must be a large force acting upward on the larger area piston to keep the pressure equal. That is how the force becomes magnified. Now, let us catch a glimpse of what we are going to create. After this activity, you will be able to understand basics of fluid pressure, understand basics of hydraulics, apply hydraulics, and create a working model of a crane.